So yeah, with layer 7, we have this API gateway product, and but I'm not here to sell you anything. But during the presentation, I'm going to talk about some patterns in which I will have links to some public GitHub repos that basically implement the pattern that I'm going to be talking about specifically with layer 7. So if you're a layer 7 user interested in how to do this or just curious in general, please take a look at those. So I like to think that identity security and API security are best friends. They're BFF. They don't wear exactly the same hat, but they definitely have coffee together in the morning. And so if you look at this Venn diagram here, this is basically what I'm trying to say is, you know, as you can tell by my white hair, you know, a long time ago when even like early standards like OAuth were starting to get used as just generic API access control, especially in the enterprise, it was like us, layer 7, and identity companies that were the first to implement those things. So they have a lot in common. So you know, today we think of OpenID Connect and OAuth as identity standards, but they're extremely relevant to us in API security. And if you look at the OAuth API security top 10, which is, you know, like one of the most used reference around, you know, cybersecurity for APIs and in general, you can see that right at the top, you know, there's concepts like authorization, authentication. It's really, you know, API security is founded on a basis of trust, and trust is based on identity. That's why there's so much overlap between those two things. So if you think about a user experience journey, or you know, I'm using an app, I will have, as part of my user experience, I'll be switching between touch points on the identity stack and touch points on what I call the Runtime API Stack, right? Such as layer 7 gateway. So for example, at the beginning, you have a login thing that takes a while, right? A login, you might be challenged, even just like a Face ID, right? You just need to put your Face ID in front of you. That takes maybe like half a second, right? That's an eternity for the identity stack. Half a second is a super long time, right? If you're using something like Okta Verify or something like that, I don't have a problem with it from a user experience perspective. It feels very easy, but it still takes an eternity. And that is an opportunity from a security perspective. When you have a lot of time at your disposal, you can do additional checks. Increase security checks. Maybe you do some risk evaluation. Maybe you're like crunching some number. That's great. There's a UX expectation here that there's a pause. You actually want this. It's okay to do stuff like that. But the problem is that this thing called zero trust tells us that we need to do continuous authentication, continuous authorization, continuous risk evaluation. Not in all cases, but in some cases, we need to have high security between those touch points with the identity infrastructure. But that is somehow colliding with the UX expectation. When you're not touching the identity stack, you want things to be responsive and fast. You're not waiting half a second for the data to come back. So what do we mean when we talk about API runtime policies, right? So, oh, I've got this thing there. Awesome. So types of runtime policies, right? We want to validate session, token, revocation, things like that. Some course entitlement check. Maybe you want to check that, you know, you've got a claim in your job that has the scope that you know, is relevant to the operation that you're doing for the specific API call. You can even do some fine-grained authorization as part of your API infrastructure. You know, we do things like rate limits and quotas and a lot of input sanitization and a lot of other things I'm not going to dig into. But for each of these things, you need to enforce these rules, right? These policies. And that gets done very often, especially in our case, ingress, or in a sidecar or an agent, or maybe there's the endpoint itself is responsible for some of these things. But the enforcement and decision can actually be decoupled, right? So delegated versus local decision. On the left side, you've got a situation where API request comes in to the runtime. You need to enforce something. you can actually delegate this to another thing. Like, hey, is this allowed? Here's the information relevant to make the decision. Decision point says yes or no. And all I have to do on the runtime is enforce the decision that somebody else told me that I have a trust relationship with. This is great because you got leaner enforcement point, which tends to yield more interop, right? Because as we'll see later, to basically make decisions in more complicated authorization rules, you need things like policy engines. You don't need to propagate the policies across the enforcement point. So basically, on the runtime enforcement, you don't even know what the decision is about. You don't need to know what the decision is about because you're passing the relevant data, and the decision point will do that for you. So whereas local decisions, the enforcement decision happens in the same scope. So why aren't centralized decisions always better? Isn't it always better if your runtime layer is leaner and if you don't have to distribute both the capability as well as the information that you need to run those rules? But the problem is that in some situations, that doesn't scale. And that's what we see at a lot of our customers. They actually can't do that. But it's not all or nothing, right? This is not binary. You know, at one end of the spectrum, let's start on the right side, you know. I like to think of it in terms of distance to decision, the D2D. So if you're doing everything on the runtime, your distance to decision is 0, right? Which is super efficient, super fast. Maybe you're delegating that decision-making to a sidecar, or maybe like a component inside your Kubernetes cluster. Your D2D goes a little bit higher, all the way to an extreme being Willy Wonka tells you, buy this service, right? I'm going to charge you per month. You can put all your authorization decision information there, and you can just point your runtime to that, right? It's just going to run as a SaaS over there, where D2D is really big. So it's not all or nothing. So let's look at an example where we are going to make the decision. What is an acceptable distance to decision? So let's think about token revocation check. So a decision tree starting from the top right. Can I reduce the access token lifespan enough to completely avoid revocation? This is really use case specific. In some cases, the user experience that comes out of that is acceptable, and you avoid the need for token revocation in the first place. So that's a great case. You're done. Don't overcomplicate things. If that's not the case, then the question you ask yourself is actually remote checking the token at every call, is that a bottleneck, right? There's some applications where you get a few hundred calls per second, right? There's applications where there's not a ton of API traffic all the time, and maybe that does work for you. And again, if that's the case, don't overcomplicate things. Centralizing the verification of a token revocation or just doing token introspection at every API call, in some case, it works. And if that's the case, then you're good to go. Otherwise, you can ask yourself, can I selectively check revocation depending on the API call, right? And is that enough? So maybe you've got an e-commerce thing and you're only going to check revocation when you're actually buying something. And maybe that's 10% of the API calls. And that's sufficient to bring down, right, the bottleneck issue and restore the performance that you require. But none of these things sometimes are working. And then you have a situation where you need to propagate token revocation information nearer to the token enforcement, nearer to the API enforcement point. So in this case, we're assuming that these are JOT tokens. You don't need to talk to the issuer in the first place. You can, by yourself validate that the token is valid and that you have enough information about it. So here's the first GitHub repo. My esteemed colleague, the author of that repo, is actually in the room here. I've got a number of layer 7 homies with me. So yeah, how should this information propagate? So you've got the identity layer, which presumably would be responsible for receiving, the revocation of a token. So if a token is revoked, then an event is published. And on the Runtime API layer, you can subscribe to these events, token revocation, right? So either you've got what I call a smart ingress, like a layer 7 gateway, that knows how to subscribe to these types of events and knows how to interpret these events and enforce the revocation of these tokens. Or you can have like a cluster level cache, right? It could be Redis, it could be something else, but something where distance decision is actually still lower. You don't need to go all the way to the identity stack in your Kubernetes cluster. You can have something that's responsible. If being the ability to ingest those events is too high a bar for the technology that you're using, then that's the other ways you can go. And there's applicable standards for that are coming out that basically are standardizing how these events are propagating. In particular, CAPE, the CAPE standard, which is really cool. And since this is not an identity conference, I would like to poke fun of my identity guys and say that, you don't actually need a standard for that. What I mean by that is that the fact that CAPE is not a standard yet or is not fully adopted doesn't mean you can't implement that pattern. Customers do that already. It's okay, right? But what's great about CAPE is that if you don't control both sides of the equation, if you're not, governing both the identity stack and the runtime API stack, then your job's harder, right? But with CAPE, if you support CAPE on the API runtime and using Microsoft as your identity provider, Azure supports CAPE, so then that's good, right? So I'm not saying standards are not needed, but they're good, but don't wait for the standard. Okay. So let's talk about actual authorization rule, because cheat a little bit when you look at it from the perspective of just revoking a token. This is a really simple binary yes or no, right? It's revoked or it's not. But when we talk about actual authorization rules, you need more than that. You need more intelligence. You need something like a policy engine to be able to basically execute on that. And different types of rules. Remember when we were listing the different scopes of API security, there's lots of different things, and different rules can have varying thresholds. There are different thresholds of over-engineering. Some decision-making can be local and some can be globalized, and that's okay. And yeah, how do you propagate information near the enforcement? So in the case of policy, then policy as code is the way to go, where basically there's a source of truth that your runtime enforcement subscribes to, and that gets baked into your runtime infrastructure. And I think what the next frontier is, in terms of what I call authorization governance, is global policies that are translated into effective policies that get distributed across your heterogeneous application stack. That's, to me, if we can get to that point, that would be amazing. Right now we're starting to see solutions where policies are distributed. There's governance solutions for that, but only for one type of solution. Think, for example, of OPA and Stara and those guys. So here's our second GitHub repo, if you're interested in that pattern. But here's propagating policy from design time to runtime. We're using a Kubernetes operator. So imagine a policy governance layer. You're making changes to rules. Maybe you're applying a rule to an existing service. Maybe you're changing a rule. Our customers have their approval process flows that vary from customer to customer, right? But eventually, your new rule gets published into a source of truth. It could be GitHub, it could be a Bitbucket, it could be whatever is appropriate in your environment. And then you've got, in your API runtime, you've got, in the case of a Kubernetes cluster, you could have something like a Kubernetes operator that subscribes to a commit on that source of truth and just takes the latest versions of those policies and redeploys nodes for your policy enforcement, your runtime API, with that updated bundle. Hybrid enforcement. So remember I was saying that you can have different layers of authorization with different D2Ds. So in this case, this is my third public GitHub repo example that you can refer to. But in this case, we have layer 7 acting as an ingress into a Kubernetes cluster which both has its own policy, its own framework that has been communicated with it, for example, such as through a Kubernetes operator. And then embedded inside of that, there are some requests to call out to an OPA rule, right? So that's good, because if you are managing policies across a really complex heterogeneous system, you might want to express some rules in OPA. You might want to express some rules in layer 7, and all these things need to work together. And it works great. So how else can I scale authorization other than distributed decision making? And here again, events-based architecture are really, really helpful. And they don't always apply based on a use case. But events-based architecture also help you do things like scaling authorization. So imagine this really textbook e-commerce scenario where there's a new event order coming in and you've got a microservice that's like, okay, I'm going to reserve the inventory, and another one that's also going to subscribe to the event and fulfill the order. And then eventually there's an order-filled event that gets picked up by a deliver microservice, initiates delivery, right? So that's really, common pattern. So imagine now you introduce, a new service, a fraud risk detection that also subscribes to these new order events, right? So you're not affecting the scaling there because you are doing a just-in-time authorization, right? As long as you complete your fraud risk detection before the fulfill event is complete, then the order gets canceled in time. And so by extracting the authorization outside of the runtime, the real-time API enforcement, you have an ability to scale your authorization without necessarily having to distribute widely that intelligence. So just-in-time authorization, eventual blocking as well is a pattern that we see in API security where you are crunching some numbers completely out of band, right? And then you come out with some insights that lead you to block a client or block a token, and these kinds of things can happen completely out of band, and that is another way how these things scale. Mike, how am I doing for time? 6:47. Okay, well, we're going to have time for questions because we are at the last slide. So, in conclusion, I would like to say that centralizing authorization can help simplify architecture, but it doesn't scale in some cases. If it does scale, I encourage you to do it because I feel that for us practitioners, we have a responsibility to lower the complexity that we create for future generations that are going to inherit that, right? So if you keep things simple and efficient, they will last many generations, and whatever you do is going to become the next mainframe. Enable your various clouds to make their own authorization decisions, right? Don't assume that you can centralize that. You can still centralize design time and governance, right? That's very different. Centralizing the authoring or the governance of your policies as opposed to the enforcing of it. Balance performance and over-engineering, and look for opportunity to decouple authorization checks using event-based architectures in order to scale better. Thanks. Any questions?
All right, thank you. So, questions? Certainly has to be questions after that. Okay, I'll start. I use patterns a lot. I think of patterns a lot as an architect and as a software developer, but I haven't seen patterns spoken of in this way as security patterns. Is that just because I'm sort of out of the loop? This seems like a unique way to start thinking about these tasks.
Why am I thinking about that? Is that basically?
Well, the first one is like, did I miss the boat? Are there bunches of these, or is this? This is the first time I've really seen this idea.
Yeah, I think that if you've gone through this before, if this is not your first rodeo and you are looking at token revocation, or you've gone through a system where you went down a path where things scaled, and then when you reach a certain scale, you run into a problem that you did not foresee, right? So these are common cases of those. So those patterns are things that maybe,
So is there like 20, 30 of these? These sound like the OWASP kind of, like, are
Right,
there a bunch of these patterns somewhere that we can find?
Yeah, maybe we should write a book about this, and this could be one of them. Or yeah.
There you go. There's your project.
That's the way we're going with that, right? Yeah.
Yep. Yep.
Awesome.
Okay. All right. Another question somewhere? We have time? All right, I'll ask another one then.
Awesome.
So where does this originate? Is this something that developers need to be focused on, design architects? Where does this pattern, like where do we first encounter it? When do we ask these questions?
So when we run into this at our customers and enterprise architects, people that are responsible for the infrastructure that powers their APIs. You know, we have a touch point to them via the Layer 7 gateway, which is part of their architecture. So those types of enterprise infrastructure, enterprise architects.
So right now, all of these solutions actually can happen outside of the code base, outside of the services, right? It happens in gateways and clusters.
That's correct. And that's another aspect of scaling as well, right? Like there's a lot of different layers or different types of policy enforcement. And, you know, there tends to be some of it. The more granular you go, the more this stays in the back-end application and the harder it is to express that in an infrastructure layer. Yeah, so it's a bit of a mixed bag.
Yes, there you go.
This is more about to OPA or not to OPA.
Yeah.
What are sort of your top 5 off the top of your head where you'd say, yeah, that's just those kinds of policies you should be thinking about using Open Policy Agent?
Yeah. Yes. Well, there's the policies that you already have, for one thing. Which, if you're not working on a greenfield project, or you know, like there's a lot of potential policies that you're inheriting, you know, right off the bat. So sometimes, you know, it would be a costly effort to migrate everything to OPA. So for sure, OPA I would say looks very flexible to me. I haven't seen it used at a very, very high scale, so I wouldn't be able to confirm with you how well it actually scales. But I do welcome the idea of having, you know, a cloud-native way of expressing those policies. So yeah, we would not discourage our customers from introducing OPA into their infrastructure. Even though we also have a policy language that does things that you could do one way or another, right? At the end of the day, we want to make it as efficient as possible for the customer.
Okay.
Okay, thank you. Thank you, Frank.
Thank you so much.